Welcome to the video on Analysis and Design of a Concrete Beam. In this video, you will structurally analyze and design the concrete beam drawn in the previous video. Open the file of the previously drawn concrete beam. Now go to the Analyze menu and click on Run Analysis. The case name lists the load cases that will be run. Here dead and modal are already set by default. Click on Run now. If the file was not saved before, you will be asked to save the file before analysis. Save the file in a separate folder, with some suitable name. The software now structurally analyzes the beam subjected to the loads, and displays analysis results. All the analysis results are generated, but it will show only one result at a time, in the Selected View tab. For instance, here it is showing moment 3 to 3, that is the bending moment about the 3-axis. This result is being shown, based on your analysis history, in the software. If you are analyzing for the first time, you might get the deformed shape result. If not, this can be viewed by going to the Display menu, and selecting Show Deformed Shape, as shown. This will display the deformed shape of the beam, on the selected tab. Now to check other analysis results of the frame. Go to the Display menu, and under Show Forces or Stresses, select Frames or Cables or Tendons. The options for different forces and stresses calculated during analysis are displayed below. Select Shear 2 to 2, which means shear force in the 1 to 2 plane. Click on Apply. The selected tab displays the shear force diagram as a fill diagram. Select the option Show Values, and click on Apply. The values of maximum and minimum shear force are displayed. Select the Fill Diagram option, and click on Apply. If you hover your cursor over the different points on the beam, it will display the shear force in the particular point. In this way, you can toggle between Fill Diagram and Show Values, as per your convenience and requirement. Now select moment 3 to 3, and click on Apply. The software displays the moment diagram for the beam, and you can either use the Fill Diagram, or Show Values, as shown. Likewise, you can explore the other forces as well. Click on OK when you are done. Now, if you right-click on the beam, the software displays the 4 important analysis result diagrams, that is, the free body diagram, the shear diagram, the moment diagram, and the deflection diagram. It is showing the maximum values of shear and moment, which you can verify by calculating manually. The maximum shear value is negative of 28.997 kN, and the maximum moment is 57.9947 kN-meter. Normally, when you calculated shear forces and bending moment in a simply supported beam of length L, carrying a uniform load of W kN per meter, the value was WL by 2 and WL square by 8 respectively. So considering the given beam, uniform load W equals 5 kN per meter, and length L equals 8 kN. If you use these values in the formula, the maximum bending moment equals 40 kN-meter, and the maximum shear force equals 20 kN as shown. The manually calculated values are not matching with the software calculated values. This is because when you calculate the values manually, you are not considering the self-weight of the beam, whereas the software considers the self-weight calculated from the properties of the beam. You can get the manually calculated values if you exclude the self-weight calculation from the beam. Click on Done. Go to the Define menu, and select Load Patterns. The Load Patterns option is for defining the different load types acting on the model. You can see that the dead load is listed in the Load Patterns. But all the options in the Load Patterns dialog box are inactive. This is because once you have run analysis on the beam, the software freezes all the data, including properties, loads, etc. You need to unlock the model to be able to change its properties. Unlocking the model will remove the analysis results, but it will not delete any property or load of model unless you change them yourself. Click on Cancel, and then click on the Unlock Model option. The dialog box asking your confirmation to unlock the model appears. Click on OK to unlock the model. you can now make changes to the properties of your model. Go to the Define menu, and select Load Patterns again. Now, the options are activated as you can see. In the space for self-weight multiplier, change the value from 1 to 0. Then click on Modify Load Pattern. The property of the dead load pattern has changed, and now the self-weight of the beam will not be considered while analyzing the beam. Click on OK. You might be wondering that the loads have disappeared in one of your view tabs. Do not worry. The loads have not been deleted. You just have to select the relevant option to display them. In the Display menu, go to Show Object Load Assigns, and choose Frame. Select the load pattern name, which is dead in this case, and then click on OK. The loads applied on the frame is now visible. And wait for the software to run the analysis. Once the analysis is done, right-click on the beam to check the analysis result diagrams. You can see that the maximum shear is now showing as 20 kN, and the maximum bending moment as 40 kN-meter. This is equal to your manually calculated values, which were done without considering self-weight of the beam. Thus, you can see that the software accurately computes the analysis results of any model depending on the properties set by you. Click on Done. But for actual analysis, you should not ignore the self-weight of any model. So unlock the model. Go to Load Patterns in the Define menu, and rechange the self-weight multiplier from 0 to 1. Click on Modify Load Pattern to register the changed value, and click on OK. You run analysis on the model again. You will now run design on the concrete beam. Please note that you cannot run design without analysis. In the Design menu, go to Concrete Frame Design, and select View or Revise Preference. This option is for selecting the standards the software should follow while running design on your model. In the Design Code option, select Indian IS 456-2000 from the drop-down list, which is the Indian IS code for reinforced concrete design. Then click on OK. Now go to the Design menu again, and select Start Design or Check of Structure under the Concrete Frame Design option. The software now designs the concrete beam. You can see the longitudinal reinforcement area in 3 areas of the beam displayed. There is a color bar that shows different colors with some values. The values indicate the ratio of stress carried in the frame to its maximum stress carrying capacity. A value more than 1 indicates stress more than its capacity. This would result in failure of the beam, and the beam would then be colored in red. Here the beam color is not red, so the beam is safe against stress. Now go to Design menu, Concrete Frame Design, and click on Verify All Members Passed. This is to check whether the frame members have passed or failed the stress or capacity check. Click on OK. If they do not pass, the corresponding notification will appear, and you have to redesign the section. In the next video, you will learn to do analysis and design in a complex concrete beam. Thanks for watching.